this problem gives us the model power equals 0.06 times speed cubed. So we're going to be using that for both parts of this problem. Part A tells us that if our speed is to be 12 knots, what power are we in need of in order to maintain this speed? So essentially, we have our S, and we know that what we're solving for is our P variable. So we're going to plug that into the model that's given to us. So P is a variable, and then we have P equals 0.06 times S, which is 12 cubed. And then we're just going to solve this equation to find what P is, and that'll be our answer for part A. So the first step is going to be our exponent, so we get power equals 0.06 times 12 cubed is 1,728. And then when we multiply this out, we get a power of 103.68 horsepower is necessary to move the ship at a speed of 12 knots. And there's our answer for part A. So moving on to part B, we're going to do a very similar approach, but this time we're plugging in our 7.5 horsepowers for P, and we're leaving S as our variable that we're solving for. So this time the equation becomes 7.5, since we're substituting for our P right there, equals 0.06 S cubed. So from right now, we're going to isolate our S variable. So our first step is going to be to divide both sides by 0.06. So we're left with S cubed equals to 125. And then finally, to get rid of this exponent on the S, we're going to take the cubed root of both sides of the equation, and we get our speed is 5 knots. So there's our solution to part B.